ओके तो हमने लास्ट क्लास में स्टेट्स ऑफ मैटर्स डिस्कस की थी। फिर उसके बाद हमने क्या किया था, हमने डिफरेंट हाँ चेंजिंग स्टेट्स डिस्कस की थी और फिर वो चेंजिंग स्टेट्स किस तरह होती हैं वो प्रोसेस देखा था, वो सीरीज ऑफ इवेंट्स डिस्कस किए थे। अच्छा, आज की क्लास थोड़ी सी प्रॉपर नहीं रहेगी क्योंकि मेरी पेंसिल ब्रेक। तो अच्छा, अब जरा ये क्वेश्चन देखिए। When warmed solid carbon dioxide changes directly into a gas, it does not become liquid. It means they are talking about that sublimation happens. Okay. Use the kinetic particle theory to describe the change in movement and arrangement of the particles during this change of state. So in this question, if you see, they didn't ask you about how this change occurs, but they ask you about the change in movement and arrangement of particles. So initially it was in which state?
Solid state.
Solid state, and then it turns into gas.
Yes.
So what is the movement of particles in solid state?
Vibrating in a fixed position.
What is the movement of particles? Yes, Khatija, you are right. Yes, how particles vibrate. The movement is vibration, right? And in gas, they move further apart and they spread out, they move freely. So the change in movement is from vibration to spread out and move freely. Then we have second thing, they ask us about arrangement. So how the particles are arranged in solid?
In a regular
Yes,
arrangement.
in a regular arrangement. You can take the help of the
Like this one.
if you don't remember. Okay, in the regular arrangement, and in gas, the arrangement is irregular, right? So that is the second point. And there we have a 3 points. So the third point will be in solid, the particles are touching to each other, are very close together, and in gas, the particles are further apart. So that is how you will write 3 points to get 3 marks. See, it has 3 marks. So you have to write these 3 points. Is this clear? Yes, Khatija?
Yes. Yes, sir.
Okay. You just take the screenshot and you take the picture and then you will note it down. Okay. Okay. Now we have discussed the. Now look at this. Butene boil at -6 degrees Celsius, right? Then they ask use the kinetic particle theory to explain what happens when butene boils. Yes, how will we answer this?
We will write the procedure that will let it to boil.
Discussed in the last class and see it's of 2 marks, so there is no need to write the whole process. We have to mention 2 points because it's of 2 marks. So first one, when it boils, it gains, the particles gain energy and move faster, and when it boils, the particles turn from liquid to gas. So when the particles becomes gas, the particles spread away. They already have evaporated when they turns into gas. It means they have already boiled. That's why they are gas now. So they spread. Yes. Yeah. Yes, Khatija. Is this clear to you as well?
Yes, sir.
And what was your good name? Manahil. Okay. Manahil, did you understand? If you want to, did you take the screenshot as well? Okay. Now we are going to discuss heating curve and cooling curve for the solid. So heating curve is basically a graphical representation to show how temperature changes when a substance is heated. So if a substance is solid, then on heating, it is going to be turned into, and then liquid is turning into gas. So heat
Yes.
curve shows the change in temperature during a solid is heated, and how the temperature changes during that heating, and what happens when the boiling or the melting takes place. So see, the graph would be like this, and I want you guys to draw this graph for understanding. So see, on y-axis, you will keep temperature, and on x-axis, you will keep the time. Okay, I'll suggest draw this. Okay, so first draw the x-axis and label the x-axis. Do not draw the purple line. Okay, first draw the x-axis and label them. You need three horizontal lines, but we are here on and that is not vertical, it's diagonal. So you need to understand this on y-axis how we will label it. Okay. So on x-axis, because we are putting the time over here on x-axis, so time would be start always from 0. But on y-axis, we are putting the temperature. So if it's a solid, then on y-axis, we label this point with a temperature that must be lower than the melting point of that solid. Because we have to show that it is initially in a solid state. That's why we always start from here. We put that temperature, which is always lower than its melting point. Is it clear to you, Fatija?
Yes, sir.
And this temperature must be higher than its boiling point. Okay. So what happens if here we have a solid? So when I heat the solid, that the temperature of the solid rises. On y-axis we have a temperature. So as the time passes, the solid gains energy and the temperature of the solid start to raise. But as the melting point reaches, the substance starts to melt. The temperature stays constant, it stays same, and all the solid turns into liquid. When we have all liquid, then temperature again start to raise till the boiling point. And when the boiling point reaches, temperature again remains constant or stays same until all the liquid boils and turns into gas. And when all we have a gas and there is no liquid, then again temperature start to rise. Is this clear? Yes, Khati?
Yes, sir.
Okay. Now if I
Yes.
ask both of you from A to B, which state exists?
Solid.
Solid. Now from B to C,
Solid. It is melting solid to liquid.
the state. solid to liquid, which means at melting point, both solid and liquid exist. Because if the melting is taking place, so there is some solid over there as well as some liquid over there. So from B to C, we have both the states, and from C to D,
Liquid.
liquid, and then D to E, liquid and gas,
Liquid.
right? And then from E onwards, we have
Gas.
gas only. So here we have a description of the graph that between the points, which state is there and what is happening over here. Note these down. Done? Yes, Khatija?
Yes, sir.
Have you done? Okay.
Yes.
Now next we have a cooling curve. Cooling curve is also the graphical representation, but it is a temperature change when a substance is cooled. Its temperature is lower, gets lower. So here we go. 1 minute. Yes. Yeah, it's ये बनवाने जल्दी से please. Yes. So if we look over here, what state exists over this point?
Gas.
Gas, because this temperature is higher than its boiling point. So when I cool the gas, its temperature start to decrease till the boiling point reaches. And when the boiling point reaches, condensation start and the vapors start turning into liquid. And as all the gas turns into liquid, temperature starts to fall again. Until the condensation is taking place, temperature stays constant. And then the temperature of the liquid starts to fall until its melting point reaches. And at melting point, when freezing occurs, the temperature stays same. And when all the liquid freezes, then further temperature decrease. Is this clear?
Yes.
Okay. Okay, now I want you to complete all the labeling, all the description, all the points. Which have you labeled all these? Show me. From C to D, which state is this? Liquid. And the temperature? What happens to the temperature from C to D? So the melting occur from B to, there is no melting, it's liquid, it's a gas. So condensation occur from B to C, and then C to D is liquid. What happens to its temperature? It
Decreases.
falls, decreases. So which states are there between D to E? And the temperature? See, there is a horizontal line, so the temperature stays constant because freezing is taking place. And then E to F, it's solid and temperature is decreasing. Is this clear? Yes.
Yes.
Okay. Then we have next thing that are factors affecting the volume of gas. And there are two factors which affect the volume of gas. One is pressure and the other one is temperature. Okay. So how do we define a pressure of a gas?
Sir, repeat your question.
I, I, I am asking how we can define the pressure of a gas.
The particles of a gas colliding in a closed container.
And to whom they are colliding?
They are colliding with the wall of the container.
They colliding with the, see, the particles of a gas can collide with two things. One is they collide with each other because they are moving, and they can collide with the walls of the container. So when they collide with the walls of a container, that makes a pressure to be exerted. Okay, so if they collide more frequently with the wall, then the pressure would be more, and if they collide less frequently with the walls of the container, then the pressure would be less. Is this clear? Yes, Khatija?
Yes, sir.
Okay. Now, so we are going to observe what happened to the volume of gas when pressure is decreased or increased. So how we can change the pressure? If we have a container and if we decrease the space of the molecules in the container, which makes the particles to gas particles to come closer to each other. Yeah, it will make them to collide more frequently. So the pressure increases and the volume decreases. But if we allow the gas molecules to be further apart, there are big spaces between the molecules, then they are going to collide with the container walls less frequently, and as a result, pressure decreases and the volume increases. Is this clear to you, Khatija, as well?
Yes.
Manahil? Okay. So note this down. Yes, if you guys have any confusion to ask. Yes. From 5:15. And on what days? Hmm? Okay, and what days beside Thursday? Which other day? So both the days you have to leave at 5:15. Yeah, do ask. Okay. Have you done till here? Khatija, have you done?
Yes, sir.
Okay. Is there any confusion? So on the basis of that, then we can conclude over here that if we increase the pressure, volume of the gas decreases at constant temperature. And why this happen? When we increase the pressure, the particles come closer and the spaces between the gas particles decreases. And as a result, the volume decreases. So there is an inverse relation. When we write like this, that V is proportional to 1 over P, it means that if we increase one thing, the other thing would decrease, which means if I increases the volume, the pressure would decrease. And if I decreases the volume, the pressure will increase. And that all happening at a constant temperature. Okay. Khatija, are you done?
Yes.
Okay. So let's look at temperature. So when we increase the temperature, the volume of gas increases at constant pressure. And why is it so? When we increase the temperature, the particles gain energy. When the particles gain energy, they move faster, and as a result, they get further away from each other. And as they get further away from each other, the gas expands and the volume increases. Yeah. Khatija, are you done?
Yes, sir.
Now look at this question. Is of 2 marks, and they have provided you some information in the question. What they are saying, a gas syringe is filled with 80 centimeter cube. It's centimeter cube, which means it's a volume of hydrogen chloride gas at 20 degrees Celsius. The syringe is placed in some hot water at 50 degrees Celsius. The atmospheric pressure does not change, but the volume of gas in the syringe increases to 88 degrees Celsius. Oh, 88 centimeter cube. See, when the gas syringe have a temperature of 20 degrees Celsius, if you look in the diagram, the volume of the gas is 80. The gas is occupying 80 centimeter cube. But when it was put in the hot water, the temperature of the gas syringe raised to 50 degrees Celsius. And as the temperature raised, the volume is also raised, which was initially 80. Now at 50 degrees Celsius, it is 88 centimeter cube. So see, now what they are asking, use the kinetic particle theory to explain why the volume increases. So how will write the answer? Increase in temperature. What will be the effect of increasing the temperature?
The volume of the gas increases.
Yes, so that's what is obvious over here. That's what is visible. Now you have to explain why. That is true, that volume of a gas is increases, and that is what we are seeing over here as well. But we have to explain the reason behind this. So what when we increase the temperature, what particles will do? Particles gain,
Get further apart.
first they gain energy and then they move further apart. So 2 marks. One is for by gaining energy, and the second one is,
Further apart.
so see, that's how you will write the answer. Is this clear? Yes, Khadija?
Yes, sir.
Okay. Now have a look at this question. It's for 1 mark. What they are saying, a gas syringe is filled with centimeter cube of ammonia gas. So the initial volume is 70 centimeter cube. Then the pressure on the plunger is increased. See, someone is pushing the plunger from upward. The temperature does not change, but the volume in the syringe decreases to 60. Initially it was 70, and when the is applied, pressure is increased, the volume decreases to 60. Now they are asking, use the kinetic particle theory to explain why the volume decreases.
Because the particles come closer to each other.
Yes, the particles come closer to each other, the space between the particles decreases. So that's how you will write the answer. Yes, it's clear to both of you.
Sir, I have a question.
Yes.
That when we are increasing the temperature, so volume is also increasing. So then here the pressure will be lower.
Where the pressure would be lower?
When we will be increasing temperature and then volume will also be increased. So
The
then
pressure
pressure will be
is
lower.
stays same. The pressure does not change. That's why volume is increasing. See, read the third statement, third line from B. That what they are saying, the atmospheric pressure does not change. So when the pressure is constant and we increase the temperature, the volume also increases. And when we decrease the temperature, the volume also decreases, but there is no change in pressure.
Okay, sir.
Next, we have a diffusion. So when we have to explain or define diffusion, we can say it is the movement of a particles or spreading of the particles. And particularly, we say that it is the movement of particles from higher concentration to the lower concentration. For example, if I spray a room freshener in this room, whether I spray it at this corner, but after some time you are going to smell it. So what happens that the molecules which are of the room freshener will travel from here to there. So it means they spread out. Sorry. Yeah, they spread out, and that spreading is diffusion. Or in other words, as the last definition says, that when I spray these particles at one corner, so at that corner initially, there are so many particles of that room freshener over here at this corner because I just sprayed it. So I can say that at this corner there is a higher concentration, and where you are sitting there is a lower concentration. So they move from their higher concentration to that lower concentration. So that is also diffusion. So if we smell anything, that smell is due to the diffusion. In the same way, when we put a drop of ink in a water, what we see that initially there is a very dark, dense color of that ink in the middle, but after some time that color spreads in the whole water. So that is also the movement or the spreading of the particles. So it is also diffusion. Is this clear?
Yes, sir.
Okay. And 1 minute. Yes, here. Well, Vidya, have you noted down?
Yes, sir.
Okay. So the particles that diffuse that must be present in the gaseous or liquid medium, then they can move from one end to another end if there is a solid. So inside solid, there is no diffusion. And why this diffusion occur in the liquid and a gas? It is because in liquid and a gas, there is a spaces between the molecules or the particles that allow the other particles of the other substance to move. And that's how diffusion occur. Is this clear?
Yes.
Okay. Done. Okay, Khadija, have you done?
Yes.
Okay. Now, next thing that we will discuss will be factors affecting the rate of diffusion, that the movement of particles. Diffusion is the movement of particles. So if the particles are moving, so it means they must be moving with some speed or some rate. So what are the things which can actually speed up the diffusion or slower down the diffusion, which means which can speed up the movement of particles or which can slower down the movement of particle. Just put the heading. We will continue this in our next class. Okay. Okay, Khatija.
Okay, sir.
Khadija, are you done?
Yes.
Okay, so uh,